In a family of four individuals, the father possessed long ears and the mother possessed short ears. If the parents had pure dominant and recessive traits respectively, and if one individual is married to an unrelated individual of the same genotype, then calculate the ratio of the genetic makeup of F2 generation. Show a suitable cross. Father has long ears, pure dominant trait. Mother has short ears, which is a recessive trait. That means the parents have pure dominant and recessive traits respectively. Now let this be the dominant allele for long ears and this be the recessive allele for short ears. Since the father is pure dominant, his genotype is this, and since the mother is pure recessive, her genotype is this. Now, the offspring inherit one allele from each parent. Thus, his cross is this. So, the Punnett square would be this. That means all F1 individuals have the heterozygous genotype, meaning they have long ears. Now, let's see F1 cross. The F1 individual is married to an unrelated individual of the same genotype. Thus, we perform the cross and we see the Punnett square. Now, F2 generation genotypic and phenotypic ratios. So, genotypic ratios would be homozygous dominant would be 1 out of 4, heterozygous would be 2 out of 4, and homozygous recessive would be 1 out of 4. That means genotypic ratio is 1 is to 2 is to 1. Now let's see the phenotypic ratios. Long ears would be 3 out of 4 and short ears would be 1 out of 4. That means our phenotypic ratio is 3 is to 1. In the F2 generation, 75% of the offspring will have long ears and 25% will have short ears. So, this is what the conclusion is. And this follows Mendel's law of segregation, where the recessive trait reappears in the F2 generation in a 3 is to 1 ratio.